So next, let us understand position time graph, and this detail will start from this point. So we know that velocity is equal to delta x by delta t is equal to x2 minus x1 divided by t2 minus t1, and that gives us slope. That gives us a slope is equal to tan theta. So this is, let us consider line number one, and it is having slope. It is having slope theta. Is it positive or negative? If theta is less than 90 degree, this is slope is positive. If you take, this is drawing number two, theta is greater than 90 degree, so this slope is negative. So what are we going to check while reading the graph or while preparing the graph? So first case, we need to check whether angle is 90 degree less than 90 degree or greater than 90 degree. So we know that if it is less than 90 degree, slope is positive, and if it is greater than 90 degree, slope is negative. So first consideration, we have to check this theta. If it is less than 90 degree, slope is positive, and if theta is greater than 90 degree, slope is negative. We need to draw slope with the x-axis. With the x-axis, you can draw x-axis here also. This is theta. We may draw here. This is theta. The next condition, if theta is equal to 0, if theta is equal to 0, that means this line is parallel to t. This line is parallel to c. So theta is equal to 0. Here we are talking about graph x versus time. This turns, or you can say displacement versus time. This turns for displacement versus time. If it is having zero slope, or you can say theta is equal to 0, object is stationary, object is raised, or simply you can say velocity is 0. Velocity is 0, or you can say object is raised. One more option is possible if theta is equal to 90 degree. If theta is equal to 90 degree means vertical line. If this line is vertical, if this line is vertical, if this line is vertical, see, that means it shows very high velocity. Practically, this is impossible case. Practically impossible case. But in examples, you may find this kind of graph, vertical lines. It shows infinite velocity. It shows infinite velocity. But practically, it won't happen. There is always a gradual increase in velocity. So you need to check first angle. If it is theta is less than 90 degree, or theta is greater than 90 degree, in the most of the cases. In very few cases, you may see theta is 90 degree, or theta is equal to 90. It is majorly not available. So first checkpoint is you need to find slope. If it is positive, then velocity is positive. Slope is positive, velocity is positive. Slope is negative, velocity is negative. Then second is, if slope is constant, velocity is constant. If you see here, if you measure slope of this line, one number, slope of this line, theta, if you measure here theta, if you measure at any position, that becomes theta. For the second case also, if I measure this or any position, this becomes theta. If I just extend this line, this becomes theta. All thetas are equal. All thetas are equal. So for the straight lines, when there is a straight line at angle, right? What it shows that velocity is constant. Velocity is constant, and if velocity is constant, acceleration is zero. If velocity is constant, acceleration is zero. So this is checkpoint number two. This is checkpoint number two. Checkpoint number three. If line is not a straight line, so you need to check whether slope increases or decreases. Say for example, there is some curvature. In this drawing, there is some curvature. If there is some curvature, Let's check what it tangent. You know that slope is, say for example, if you take point from this position, so slope is tangent, which we can draw. We can take one more point here. We can draw slope. It is here, and let's change the color. So the first point we know that theta 1 and the second point theta 2. Can we say theta 1 is less than theta 2? Yes, of course. So what we can say here, we can conclude here, slope increases. Slope increases. Theta 1 is less than theta 2. Slope increases. Again. Let's see again. We know the tangent. If I draw tangent, so it is a tangent gives slope of that instant. Say for example, point A. And if I draw tangent with some different color, let's take this red color, and let's have blue as angle. So this is theta A, this is theta B. Can I say theta A is less than theta B? That means slope increases continuously. If slope increases, meaning is that velocity increases. If slope increases, velocity increases. See, if you see here with this time, say for example 10 second distance travel, maybe 10. Take further 10 second distance travel looks like more than 30. For the similar 10 second it is, so what we know, velocity is equal to 30 by 10 is equal to 3 something. In the previous case it was 10 by 10 is equal to 1. So 3 is bigger value than 1. 3 is bigger value than 1. That means what? Velocity increases. See, velocity increases. In the other word, we can say acceleration is positive. Acceleration is positive. Acceleration. See, velocity increases means what? If acceleration is positive, then only velocity increases. If there is some acceleration, then only speed increases or velocity increases. Therefore, acceleration is positive. Acceleration is supporting increase of velocity. So you have to understand this part. Similar opposite is also true. If slope decreases, velocity decreases, and there is a negative acceleration. Acceleration should be negative. If there is a retardation, then only velocity decreases. We understand that. We understand very well. So this two you have to remember. Then what next? Then we can compare here. Right. So before that, let's also take one more example. If I want to have tangent, so you can take Tichuk. This is and another tangent here. This is Tichuk, Tichuk. Let's take this is point number A and this is theta A, and this is point number B, and I can take parallel line. This is theta B. Can I say theta A is greater than theta B? That means angle decreases. We can have this case. Right. And in third case, if you see here, this is, let's just take this position. Let's take one Tichuk here, second Tichuk here. So what is the case? This is theta 1, this is theta 2. Theta 1 is smaller than theta 2, so angle increases, velocity increases. And for this half, another half, let's take here one Tichuk and another Tichuk here. So this become theta A, this become theta B. Can I say theta A is greater than theta B? That means angle decreases, velocity decreases, negative acceleration. And the last checkpoint, when there are comparison between two lines, so if we just compare theta 1 and theta 2, just see this drawing, top right hand top cover. So shallow slope, we can say this is theta A, and the steep slope, that is theta B. See, we know that theta B is greater than theta A. That means theta B slope represent higher velocity. If the steep slope, it represent higher velocity. A bigger slope it is having a bigger velocity. It is having bigger velocity. So this four you need to remember. You need to remember that part. And there is also shortcut. There is also shortcut for that. For that, for the acceleration time graph, there is also shortcut. You can identify whether acceleration is positive or negative. Now, if you see this, is it visible to you? Yes, it is visible. You can see here. This is a shape. We can see here. We can see here. This is a shape. This is a shape. This is a shape. We can see here. What is the name of this shape? This is known as concave. This is known as concave shape. Concave shape. This is a concave shape, like a vessel. Vessel. Most of the vessels are having this kind of shape. Katora. It is having this kind of shape. So this shape is known as concave shape. If we take if we move from this point, first position theta 1, this is tangent, it is showing the first position theta 1, theta 2, here it is theta 2, like that, theta 3, theta 4, theta 5, theta 4, theta 5. If you see here slope, so first m1 is having the biggest, largest slope. We know that this is the theta 1, this is the for the first one. This line is having theta 1. It is the biggest one. It is the largest one. If we take here theta 2, it is slightly smaller. So here m1 is less than m2, less than m3, less than m4, less than m5. So you can see there is a slope in this case continuously increases. Is it like that? Slope is continuously increasing. That means acceleration is positive. There is an increase of acceleration. So whenever you see there is a concave shape, always consider acceleration as a positive value. Always consider acceleration as a positive value. And if this is shape, this is convex. This is convex. Another shape, it is convex. This shape is a convex shape, and when there is a convex shape, acceleration is always negative. Acceleration is always negative. So slope m1 is having the biggest, then slope decreases, slope decreases. You may try also. You may try by yourself also. So this is a shortcut when there is a concave shape of graph, positive acceleration. Or it is also vice versa. If acceleration is positive, graph is always concave, and if acceleration is negative, graph is concave. Which graph? Position time. We are talking about position time, right? We are talking about position time graph. Now, in the case of velocity time graph, what we are going to learn here. So, if velocity and acceleration both are having similar size, that means both are positive or both are negative. If both are having positive, that means velocity increases. See, if velocity direction it is positive and acceleration is also having positive direction, that means both are supporting each other. So there is an increase of velocity. There is an increase of velocity. If velocity is negative direction, acceleration is also negative direction. That means both are supporting in the negative direction, accelerating v velocity in the negative direction. That means there is an increase of velocity in the negative direction. So that is the case. Second is if velocity and acceleration both are having opposite sign. In this case, velocity decreases. Velocity decreases. If acceleration is negative, in this case also velocity decreases. If velocity is negative, in this case, velocity decreases. Let's see. So what are the four options are possible? One is velocity. Say for example, if you draw a graph like that, this is graph y, displacement versus time graph. If you draw a graph, right? So here, with the increase of velocity, velocity is increases. So what happen? Both are having velocity as well as acceleration. Both are increases. Therefore, velocity is also, if you just draw a graph for the velocity, so velocity is also increases. If velocity is positive, but acceleration is negative. Negative acceleration means there is a reduction. It is taking velocity reduced side. So that means velocity decreases. You draw graph for that. So velocity decreases. Similar case, when there is a negative velocity, if you draw graph velocity versus time, if there is a negative velocity and acceleration is positive, right? If there is a velocity is negative, so it what happened? It decreases, but in the negative direction. See, line goes in the upper side, but here it is minus v, minus 1, minus 2, minus 3, right? So in this case, if it is minus 3, because of this negative acceleration, it become after some time it become minus 1. So it is decreasing. In the direction you have to understand that part. And in the last part, if velocity is negative, say for example, negative 1, and there is a negative acceleration, that means it is again decreasing. But see, if you see it is minus 2, minus 3, so actually it is increasing in the negative direction. So you have to understand this concept very well. So now we have better understanding of position time graph. One graph is shown here as a sample position time graph of two different objects. Say for example, X object number B, it starts from distance, say for example 10, and object number B, it is starting from 20. And both are moving in a straight line. Both are moving in a straight line. So what we can call for this two lines? See, if we take angle this theta of A and theta of B, so in this case, we can say theta A is equal to theta B. And this angle represent velocity. So that means both the parallel lines always shows equal velocity. So this is very simple concept that need to understand. There is a one more for that. See, you can see there is a another drawing. We will understand in more detail with a different example with more understanding. So let's see first it is A. This is line number A is given. This is line number B is given. So if we just take theta, this is theta A and this is theta B. So can I say theta A is greater than theta B? That means what? Velocity of A is greater than velocity of B. We are not discussing about other components as of now. We just talk about velocities, right? So both are having unequal velocities and velocity A is greater than velocity B. Let's have one more. So A position is given. If we take this, so this gives us theta A, and here this becomes theta B. See, theta A is less than 90 degree, theta B is greater than 90 degree. That means what? A is having positive velocity and B is having negative velocity. A is having positive velocity, B is having negative velocity. In addition to that, suppose if I draw horizontal line and if this is theta A and if I draw another one theta B, if both are equal, that means both are having equal and opposite direction. So let us read different graphs. Which graphs? Position time graphs. So first, if you see the first graph, A is having one axis, it is X, it is showing position, and the opposite side it is showing time. So graph, it is having slope is 0. So see, we already have conclusion when there is a slope is 0, that means velocity is 0, velocity is 0 and object is stationary. Object is stationary. That we know it very well. So slope is 0, velocity is 0, acceleration is 0, it is not required even to check. So body at rest, body at rest. First example is very simple. Now we need to check example number 2 B. It is given here B. So there is an inclined line. It is X and T is shown. What is first check? We should check first angle theta. Is it less than 90 degree? Yes, it is less than 90 degree. That means here in this case slope is positive. Slope is positive. Slope is positive. M is positive. Ultimately we can write velocity is also positive. So from that first we identified velocity is positive. There is a velocity and there is a positive velocity. What about acceleration? What about acceleration? So see here, velocity is constant because slope is constant. Slope is not changing. If you see angle of the slope, so that angle is theta 1, that angle is theta 2. We know that theta 1 is equal to theta 2. Slope is constant. That means acceleration is 0. Acceleration is 0. Right. See, we already concluded that part. Here theta is less than 90 degree, that we already check here. Theta is 90 degree less than. So slope is positive, velocity is positive. Second, slope is constant, theta 1. If you measure here or anywhere, it is having equal. That means acceleration is 0. Acceleration is 0. So first two examples are very simple to identify. Third, if you see here, there is some curvature is showing x and t diagram or graph. It is showing some kind of curvature. So what is our first check? First check, we can check angle. So let's take tangent here, somewhere tangent, and this is theta. Is it less than 90 degree? Is it less than 90 degree? Yes, theta is less than 90 degree. Ultimate, it gives velocity as positive. Velocity is positive. And what is our second check? What is our second check? You can take theta 1 and theta 2 as a comparison, and you can say that theta 1 is less than theta 2. But our conclusion, what is our conclusion? What is our conclusion? Or direct shortcut. See this shape, see this shape, see this shape. Can we say it is a concave? Can we say this shape is concave? Yes, if there is a concave, that means acceleration is negative. Acceleration is negative and it graph start from 0. Fine. So let us again bodies, not the previous one here. Theta is less than 90 degree, that already checked. So slope is positive, right? This theta tangent, we can take tangent theta less than 90 degrees, so slope is positive. Then what is next? The shape of this curve. What is this? This entire curve is concave. For the concave, acceleration is positive. Acceleration is positive. That means velocity increases. Velocity increases. So velocity is positive. Acceleration is positive. Ultimately, what it gives? It gives increase of velocity. Increase of velocity. So that is our conclusion. Object starts from the rest or origin with positive acceleration and positive velocity. Velocity increases with time. Velocity increases with time. Let's have D. Let's have D. So what is our first check? So our first check is to check slope. Let's have this point. Let's have this point. Tangent. I want to do a tangent. Can I say theta is less than 90 degree? Yes, that means velocity is positive. Wow. velocity is positive. Velocity is positive. So theta is less than 90 degrees. Slope is positive. Velocity is positive. Velocity is positive. Good. Then what is second check? Second check is that shape. Is it convex? Yes, it is convex. If shape is convex, what should be acceleration? Acceleration should be negative. Acceleration should be negative. Shape is convex, negative. So here we have velocity as a positive, acceleration is negative. So ultimately, what it become? Velocity is positive. Say for example, in the graph of v and t, in the graph of v and t, velocity may be starting from here, positive. But see, acceleration is negative. Acceleration is negative. That means velocity decreases. Velocity decreases with time. Velocity decreases with time because of acceleration, negative acceleration. So what is our conclusion? So object starts from the rest, or you can say origin from this point, and then negative acceleration with positive velocity. Velocity decreases with time. Velocity decreases with time. Very simple understanding. And the last one. And the last one. Can you solve this and comment me? Or you should pause the video from here and can you comment from the graph number E? Let us just break this graph from here, right? So part number one, this part, if you take tangent, so this is less than 90 degree. Is it less than 90 degree? Theta less than 90 degree. Yes. Let us take from this position. Can I take this theta is less than 90 degree? Yes. So see, for all the cases theta is less than 90 degree. That means velocity is positive. That means velocity is positive. That we identified. Good. Second check, yeah, cup. Just check cup. First, this is the first portion. For the first portion, what is the shape? It is concave. When there is a concave, acceleration is positive. So for the first portion, it is concave. And what about second portion? What about second portion? It is convex. So it is negative acceleration. Right. So first there is a positive acceleration, then there is a negative acceleration. Wow, wow, wow. So for the first half, positive acceleration, second half, negative acceleration. So for the first half, velocity increases, and for the second half, velocity decreases. Right. For the first half, velocity increases, second half, velocity decreases. So conclusion is starts from the origin from the zero, body accelerates first, accelerates, then decelerates. Body accelerates from decelerates. Isn't it simple? Yeah, it is very. We will be solving so many examples, so I don't think you will be having any confusion after studying this session. So let's go. Oh, few more examples. Few more examples. Wow. So we can see, let's have this is one, this is two, this is three. So let us checking first. So what is our first check? First check is theta. First we will be checking theta. So let's take tangent. Let's take tangent here. And what about this angle? Less than 90 degrees. So what is our conclusion? It is positive. It is positive. It is positive. Wow, great. Then what is second check? Second check is shape. Shape. It is concave. That means acceleration is positive. Acceleration is positive. So acceleration is positive, velocity is positive, both are positive. So velocity increases, velocity increases, right? So in the case of, let's call this f. So in this case, velocity increases and velocity starts from x0, or object starts from x0. It is not starting from the rest, but it is starting from the x0 at t0 time. So that is the case. So body starts from positive x0 with positive velocity and with the positive acceleration, and velocity increases. That is our conclusion. Good. So we have seen f. This is our f. This is answer G. Good. So first check it is slope. This theta, can I say this theta greater than 90 degree? Yes, that means slope is negative, velocity is also negative. Good. Then this straight line, velocity constant, acceleration 0. Velocity constant, acceleration 0, and velocity it is decreasing. Velocity is decreasing with time. So velocity is constant, right? And it is not decreasing. It is velocity is constant, but it is negative velocity, only negative velocity. How can you confuse me? Don't confuse me. So solution is body starts from x0 and have constant velocity and negative velocity. Negative velocity. Good. Oh, this is another case. Body starts from x0. Body starts from x0. Then let's do from here, tangent. Let's go for the tangent. What about angle? What about angle? Theta is greater than 90 degree. That means velocity negative. So first check is theta greater than 90, velocity negative, and the shape. Next is shape. Oh, convex. Convex means acceleration negative. Velocity negative, acceleration negative. Velocity increases in negative direction. Velocity increases in the negative direction. Velocity increases in the negative direction, in this direction. Or you can say simply, we can say velocity decreases. Velocity decreases. Right. So see here, it is going towards negative side. If you extend this and go in the uh, you can say downward direction, right? So this is h. This is h. Body starts from positive and then negative acceleration, negative right direction, and velocity increases in negative direction, right? So see here, if you plot graph v versus t, so here graph starts from negative, graph starts from negative, right? Velocity, negative velocity, and it goes like that. So it increases in the negative direction, because if it is taking -1, so it is -3. So -3 velocity is greater than -1 velocity. Don't confuse with math. The next is position time diagram, and you have very difficult, difficult part. So we have to divide this into up to O to T1 portion, up to O to T1 portion. Let us take angle theta. Theta is less than 90 degrees. So velocity is position. For the first half, velocity is position. Wow, velocity is positive. Velocity is positive. Velocity is positive. And what about shape? Shape is concave. Shape is concave. The meaning is acceleration is negative. And for the second half, tangent. Let's do tangent. This is theta greater than 90 degrees. So here it is having negative velocity. In this side is having positive velocity. Wow, great. And in all the case, entire case, acceleration is negative because shape is convex. Yeah, this is not concave, it is convex. How can you make such mistake? Don't make. So it is having negative acceleration. So for the first half, velocity is positive, acceleration is negative. So what happened? Velocity decreases. Velocity decreases. So if we draw a velocity versus time graph, so velocity start from the positive, then it decreases, then it decreases. Right. For the second half, negative velocity, negative acceleration, negative velocity, so velocity start from negative v, and then it increases. Increases means what? -1, like -3. So it going like that. It increases in this direction, increases in this direction, right? Don't confuse with direction negative, positive, otherwise you will have wrong answer. So body starts from the origin, and then velocity of body decreases, velocity of body decreases, velocity of body decreases, and becomes zero when there is a no slope. So here there is a no slope, no slope. No, it is slope, but slope is zero. Slope is zero, slope is no slope. So at that time at t1, it is momentary, velocity is zero, and then it decreases, it decreases, it decreases. Reverse direction, and reverse direction increases. See, if you just consider a ball is thrown vertically in the upward direction. So what happens? It is having here, it is having maximum velocity. Then velocity decreases when ball reaches to top position. Velocity is equal to zero. Then it goes downward direction. So downward direction velocity is negative. Negative velocity increases, decreases, velocity increases, and here when it strike on the ground, negative velocity is maximum. And here acceleration is equal to minus g. It is the similar example. It is the same example I'm talking about. Isn't it nice? Of course, nice. Oh, one more opposite graph. Opposite graph. So let's divide. This is segment number one. This is segment number two. What is our first task? First task is to check angle. Yeah, great, great answer. So this is angle. Let's check angle. You have to go with T line, horizontal line, and this is the angle theta. One. Can I say one greater than 90 degree? Yes. That means for this portion, velocity is negative. Velocity is negative for this portion. Yes. And for this second, let's do tangent, let's do tangent, let's do tangent. This is theta 2. Can I say less than 90 degree? Yes. So velocity is positive for this section. Good. What about shape? What about shape? Shape is convex. That means acceleration is positive. Now we have everything great. For the first half, theta is greater than 90, so negative velocity. For the second half, theta is less than 90 degrees, so it is positive velocity. Great. And what about acceleration? Acceleration is always positive. It is always positive. Wow. So for the first half, velocity negative, acceleration positive. So what happened? Negative velocity decreases. If I do a graph, this is velocity and it is t, so it is having negative velocity somewhere here. Negative velocity, and there is a acceleration. So negative velocity decreases, so decreases negative velocity in this direction. Right? Don't confuse with the direction, otherwise you will have a big problem. And then second half, velocity positive, acceleration positive. What happened? This is v versus t graph. Velocity is positive, so it is above line, and it increases because acceleration increases. So it is like that. Great. I think you have understood that part. This example is ex- exactly mirror of the last example. So body starts from origin. Yes. Then velocity of body decreasing till t1. There is a decrease of velocity. Then here zero. So here it is maximum velocity. Decreases velocity, decreases velocity, decreases velocity. Here it is zero. Then velocity increases, that velocity increases, and here it is maximum velocity. You don't get confused with positive negative side, otherwise you will have huge problem. You repeat, right? You repeat the session again and again, then only you will be able to understand. And acceleration is always positive. It is like a reverse gravity kind of phenomena. It is taken here. Oh, one more example. One more example. Wow. So what is our first check? First check is check angle, tangent, tangent, tangent. Can I say theta is greater than 90 degree? Yes, sir. That means velocity is negative. Slope is negative, velocity negative. Second, shape is convex. means acceleration negative. Both are negative, so velocity increases in negative direction. Here it is t v, velocity negative v increases in the negative direction. Good. So body starts from the origin. Velocity of body increases in negative direction with negative velocity. Great. With negative direction.